Hello everyone, welcome back to the Aspen channel. So far we have uploaded various videos related to the simulation, related to design and so on. But now today our focus will be on economic analysis in addition to the simulation of compressor, and we will be doing this in Aspen HYSYS. So before starting this activity, if you have not subscribed the channel, please do subscribe the channel, click on the bell icon to get all updates related to this channel. So in this activity, which is related to the compressor simulation and economic analysis, we have been given that temperature of the inlet stream is 25 degrees centigrade, the pressure is 1 bar, the molar flow rate is 1500 kg per hour, and the composition of the mixture is methane 0.943352, ethane 0.041257, propane 0.00988, butane 0.003227, and remaining quantity 0.002284 is of nitrogen. And obviously, the inlet conditions and outlet conditions for flow rate and for composition will remain the same. And we have to compute the outlet pressure and the temperature. And for compressor, we have been given that the delta P is 10 bar and adiabatic efficiency is 80%. So first we will do the compressor simulation, and in the second part we will be doing the economic analysis and comparing the cost of various types of compressors. So adding these components one by one: methane, ethane, propane, butane, and nitrogen. So all the required components are added in the system, going to the fluid package using Peng-Robinson as the thermodynamic property package or fluid package. Going to the simulation, selecting compressor, and again doing the connections. We have already done that various times: inlet, outlet, energy, and we can name it as K100 or compressor. Now we have been given that it is 25 degrees centigrade, 1 bar, 1500 kg mole per hour, and the composition I will simply copy paste it from Excel, and as you can see all the values are copy pasted and the total composition is 1. Now we have been given that delta P, which is coming to design and parameters, delta P is 10 bar and adiabatic efficiency is 80%. So with adiabatic efficiency of 80% and delta P of 10 bar, we can see that for centrifugal compressor, the duty required is 4002.62 kilowatt. If we convert it to reciprocating, power is same. Screw compressor, power is same. So this is the first part of our activity where we have solved or we have simulated the compressor, and remaining properties are there, like 11 bar is outlet pressure, temperature is 248.8 degrees centigrade. Now closing it, and as you can see, we have seen before, I maximize it, that this is the economics, capital cost, utility cost. And if you come here in home in economics, then stream price, process utilities, various information is given over here. But first we need to click on this economics active, and once we have to active this to start our economic process in the system. Once after economic is active, we need to map it, and clicking on this map and it will load, and you see there are different step: mapping, sizing, and evaluation. So as you can see, this screen has pop up. Number one is the source, map, selected unit operations or all unit operations. So obviously we have to always select that all unit operations unless we are interested in some particular equipment only. Then the basis, last mapping or default. Default means that it will start from 0, and last mapping means that it will start from the last point which was mapped. Then evaluate options, it will obviously we have to select size equipment and evaluate cost. Custom size can be used, but for the time being we are ignoring it. So size equipment, evaluate cost, default, and map all unit operations. So once we click on OK, it has opened compressor, equipment type DGC centrifugal, description is centrifugal compressor horizontal. So we will first just click on OK to let it evaluate the cost for the centrifugal compressor. So now it has given us a capital cost and utility cost, and if we click on it, you can see that in summary, the total capital cost, the total operating cost, utilities cost, there is no raw material cost because we have not specified it, and there is no product sale cost because we have not again specified it. Equipment cost and total installed cost. Then in go to utilities, the electricity cost is calculated. Going to unit operations, equipment cost, installed cost, equipment weight, installed weight, and utility cost is calculated over here. Then going to this equipment, all the information is given, and in the centrifugal compressor, if you scroll it down, you can get all the information like actual gas flow inlet, design gauge pressure, design temperature inlet, outlet, and all the information. Again, molecular weight, specific heat ratio, compressibility factor inlet, compressibility factor outlet, and the driver type. So all the information is computed once you use the economic analysis. Now we have calculated this for the centrifugal compressor. And if we want to do it now for the other types of compressor, what we need to do? We need to again click on this map all unit operations, default, size equipment, evaluate cost, click OK, and click on this equipment type, going to this compressors and blower because we are dealing with this, and other informations are available if we are using heat exchangers, packings, pumps, etc. It's up to you. Click on OK. It's a gas compressor, obviously it's not an air compressor. Click on OK, and like you can select centrifugal integral gear, click OK, and then click OK, and again the cycle will run, and you can see the equipment cost, installed weight, all the information is calculated again. Now changing it and mapping the same fashion, size equipment, evaluate cost, and using compressors and blowers, okay, gas compressor, okay, and now choosing reciprocating compressor and selecting what it gives the information to us. And again it will provide some values of installed cost, equipment weight, and so on, as you can see going to this unit operations. And again click on this map and going to size equipment, evaluate cost, and selecting the last one, which was the reciprocating compressor with integral gas engine. Okay, and okay. And it has, again you can see capital cost, schedule cost is calculating over here, and the processing evaluation results. So all these results are now calculated. And what I have done, I have taken all these results to MS Excel to see which of the compressor type is the best, which is giving us the minimum cost, and which of the compressor type is giving us the maximum cost. So as you can see, all the calculated data is pasted over here, and you can see the centrifugal compressor, which is highlighted as orange, is the expensive of these, because you can see the highest cost is associated among four with the centrifugal compressor. And centrifugal compressor integral gear, the lowest cost is associated with this in terms of equipment cost, in terms of installed cost, in terms of equipment weight, and in terms of installed weight. So this is how you can compare the different types of compressors, and on the basis of the cost using economic analyzer. This is Aspen economic analyzer which have been used. Once you click on the send to APEA, which is this one, if we click on this active button, if it is active, and if we take it to the other software, which is Aspen economic analyzer, we can also do that calculations over there, but that will be part of our upcoming videos. We have currently used the inbuilt economic analyzer, and we have generated the economic summary and the economic data from this, and we have computed that for the compressor which we have simulated for the system, we have computed the cost for four different types: centrifugal compressor, integral gear, reciprocating compressor, and reciprocating compressor integral gas engine. And we have computed the values of all the cost and weight for this, and we have concluded that centrifugal compressor integral gear is the best one for the system. So that's it from this lecture. Thank you so much. Please do watch, like, share the video, and subscribe to the channel. Also click on the bell icon to get all updates related to this channel. Please stay tuned for more exciting videos on this channel. Till then, it's goodbye. Stay tuned.